So today we are going to do trigonometry. Trigonometry. That's what we are going to do. Now, on our trick, we are going to consider the theory of Pythagoras. We are going to consider the theory of Pythagoras theorem. We are going to consider the trig identities that would have to do with the cos, sine, because we are going to do elective mass. We are going to consider the sec, the cosec, the tan, and the rest. We are going to consider, or if it was to be only commas, we would have just considered sine, cosine, and tangent. But if it's elective mass, we are going to consider the cosec, the secants, and those things. We are going to consider all these things. And from there, we are going to consider the right angle triangle. We are going to consider various angles and so on and so forth. We are going to also consider the Cartesian plane and their corresponding signs in each of the Cartesian, which of the trig identities correspond to maybe a positive or a negative value or something. I'm going to consider all these things, and after the class, you will understand everything. So basically, that's what we are going to do, and so more, so on and so forth. So that is it. Now, let's first start by defining what trigonometry is. Now, when we say trigonometry, is a branch of mathematics that which deals with the measurement of sides. So trigonometry is a branch of mathematics which deals with the measurements of sides, and deals with the measurement of angles, of triangles, and their relationship with each other. So it first has to do with measurement of so we are going to talk about the measurement of side, measurement of sides. We're also going to talk about measurement of angles, angles of triangles, angles, and the relationship between them. Measure. So these are one or two things we are going to talk. That's what. And then from there, we are also going to talk about normally the applications in this engineering fields and so on and so forth. They are normally applied in the engineering fields, so on and so forth. So basically, that's what we are going to talk about. Now, having explained what trigonometry itself is, we are going to delve much deeper into what we call the theory of Pythagoras. The theory of Pythagoras. And as we know, when we are talking about Pythagoras, the first thing we consider is a right angled triangle. That's enough to help us understand when we talk of Pythagoras, what it means. And so we are going to have the diagram of a Pythagoras, what do you call it? A right angle triangle. That is what we are going to use to explain what a Pythagoras theory is. And that will also help us to talk about the angles and so on and so forth, or the trig identities. And I know these things, the Pythagoras, I know you studied this at JHS or somewhere, or unless I'm lying. I hope you guys have studied before.
Yes.
So when you talk of Pythagoras, at least you should know what you know what you are talking about. You know what you are talking about. So that's it. So according to Pythagoras theory, Pythagoras theorem. According to Pythagoras theorem, for instance, there's a right angle triangle. Now, you all know what a right angle triangle is. You all know what a right angle triangle is. So, considering a right angle triangle, we know that this vertical line is perpendicular to this horizontal line. And when it is perpendicular, then that means it makes an angle of 90 degrees Celsius. And so we assume, or we know that here is 90 degrees Celsius. Now, when here becomes 90 degrees Celsius, the summation of the angles of a triangle is up to 180. So definitely they are going to divide. And so that will be 180 minus 90 will give us 90. So we assume that here is supposed to be 45. Here is supposed to be 45. That's what it means. So that is it. Now, when we have a triangle, let's name here A, You can have here to be B. You can have here to be C. Now we can also name the sides. The sides, we can name the sides to maybe X. Here can be X. We can name here to be Y. We can name here to be Z. Now the Pythagoras theorem is what do you call it? The theory that is used or that enables us find the size of what do you call it? The triangle, just as we studied under trigonometry. It helps us to be able to calculate the size of a rectangle, sorry, a triangle. It also helps us to calculate the angles of these triangles. And so, according to Pythagoras theorem, we have names for all these things depending on the angle. So you bear with me that anytime two lines meet at an angle, or two lines meet, they create an angle. You realize that this one is creating an angle. There's an angle here. There's also another angle here, and there's also another angle here. So depending on the angle, that will also tell us the names of the sides. Now we have three main names of the sides. We have the adjacent, we have the what do you call it? We have the hypotenuse, and we have the opposite. Now when we talk of the adjacent or the adjacent is the side next to the angle under the consideration. So the side next to the angle under consideration is what we call the adjacent. Now the side which is opposite to the angle under consideration is what we call the opposite. Is what we call the opposite. Now the hypotenuse is the longest side of the side opposite to the right angle. And so the side opposite to the right angle will always be your hypotenuse. Now when we talk of the right angle, this is the right angle. This is the right angle. And so this side is opposite to this right angle. So this side becomes a hypotenuse. So y here is hypotenuse. Y here is our hypotenuse. We can just simply write hypo. And as you realize that the hypo is the longest side. Now, before we can be able to get the opposite or the adjacent, the definition of adjacent makes us understand that is the angle which is next to the angle, is the side next to the angle under consideration. So for instance, if we are considering the angle here, then that means the opposite, the angle here, this is the side next to the angle we are considering. So if you are considering this angle, or if this angle is under consideration, then that means this side becomes adjacent. Then the opposite of this becomes the side opposite to this angle becomes opposite. I hope I've made myself clear. On the other hand,
Yes,
if you are to consider this angle, or if this angle is under consideration, then you bear with me that this is the side just next to the angle. So here becomes the adjacent of this one. Then this one now becomes the opposite of this angle. I hope you get it too. You get it too.
Yes, sir. Yes, sir.
So now let's consider this angle, the angle here. So when you consider the angle here, then here becomes adjacent. ADJ. Adjacent. Then here becomes opposite, right? OPP. Now, according to Pythagoras theorem, when we have something like this, how we calculate it? You are saying that the square root of the hypotenuse, which is y here, should be equal to the addition of the square of the opposite and the adjacent. And so that means it's equal to x squared plus y squared.
Z squared. Sir.
Sorry, z squared. Thank you. Z squared. I hope you get it to this point.
Yes, sir. Yes, sir.
So now we all know how when we talk of hypotenuse and so on and so forth. So this means that mathematically, if you want to calculate for the side of so this one, according to our diagram, this one is our opposite. This one is our opposite, and this one is our adjacent. So if you are to calculate for the question, if you are to calculate for what do you call it, the z or the z, then that means you would have to bring this one here. Then you square root it so that we can cancel this one, then find for z. I hope I've been myself clear. That's mathematics.
Yes, sir.
Good. So let's try. So let's try one distance. Find the length of. Find the length of using the same diagram. Find the length of. Find the length of x, or find the length of AC. This is AC. So find the find the length of CB. There's a CB. Find the length of CB. Given y hypotenuse to be 13 and our opposite to be 5 cm. And so given this one to be 13 and given this one to be 5 cm, find the length of this. Let's do it. So given this one is 13, this one is 5. Find the length of this. Let's do it and see.
Sir, 12.
Let's stop 12 cm. So you add the units, please. Okay, I didn't add the units. I cm, so you add the unit because it's length. What did you get? PSA, what did you get?
12 cm.
12 cm. Okay, good. Now, from here, having understood the Pythagoras theorem, then now you bring the trigonometric ratios of acute angles. You know, when we say acute angles, I hope you know what acute angles are. Angles which are not more than 90 and not less than 0. So they range between 0 and 90. And so this is the acute angle. There's an acute angle. There's an acute angle. And so they are acute angles. So we are going to consider the trigonometric ratios of acute angles. Now, I told you under elective maths, we are going to consider the sine, we are going to consider the tan, we are going to consider the cosine, we are going to consider the secant, we are going to consider the cosecant, which we call the cosec, and we are going to consider the cotangent or cotan. We are going to consider all these things. That's under elective maths. If it was to be in commerce, we are just only going to consider sine, tan, cos, or cosine. So now, using the same diagram, let me right here, let me change the color. Trigonometric ratios. So that's the first thing we are going to consider of an acute angle. I won't add all those things. And so now, I said we are going to consider the sine, the cosine, and the tangent. And so, looking at this same diagram, we are given that sine, what is sine theta? Because sine, we are talking about angles here. So here we are considering angles. So our sine theta, let's represent it by K. Our sine theta, or maybe our sine C. So C becomes a theta here. Should be equal to, sine is always equal to the name, we use the name SOHCAHTOA. SOHCAHTOA. When I finish, I write it. So we use the name SOHCAHTOA. That will help you to be able to understand it. The so means opposite all over hypotenuse. The ka means cos is given by adjacent all over hypotenuse. And the toa means tan is given by opposite all over adjacent. I hope you are getting it. So the sono means SOH, and the S means sine is equal to the OH is opposite all over hypotenuse. And so this one I'm going to get OPP all over hypo according to our formula. Now the K, which is the cos, so cos C is equal to cos C is equal to cos C is equal to K is what? Adjacent all over hypotenuse, hypo. Now, using the same formula, so using the same distance. Now, we have tangent, which comes from the word tangent. That's why yesterday we were finding, when we were given that a tangent is something. When we were finding for the gradient, we just use a tangent. We found the tangent of the angle. That give us our what do you call it? Our change in y by x, or our gradient. So tan c is equal to tan is what? Twa. So opposite all over hypotenuse, adjacent. So opposite all over adjacent. Now that is it. Now from there we also have other identities that are gotten from these things, manipulations of these things, and they all boils down to this. Now we have, after tan, we have something called secant. Secant. In other words, we call it sec. Secant is also given by hypotenuse all over adjacent. Hypotenuse, hypo, all over adjacent. Adjacent. When we finish, we are going to do all these things. Now from there we also have cosecant. So we have the cosecant, secant, or cosec. Is given by hypotenuse all over opposite sides. So this one is given by hypo all over adjacent. Sorry, all over opposite. Now from there we have what do you call it? The short name of the cosecant is cosec. The short name for the secant is sec. That of the tangent is tan. That of the cosine is cos. That of the sine is sine. So that is it. Now, the last one we are going to consider under elective, we are going to consider the cotangent. Cotangent. Cotangent is adjacent all over opposite. Adjacent all over opposite. That's what we have. Adjacent all over opposite. That's what we have.
So you mean that the secant and the cosecant were gotten from the tangent?
Is that it means that what?
The secant and the cosecant were gotten from the sine from the tangent.
Yeah, so the free ones, the free new ones we've added that we are new to, they were all getting from this. They were all gotten from this. Now, when we delve deeper, I'm going to explain. I'm going to see when we do the deductions or when we relate them in terms of mathematics, you understand how it works. So you realize that some of them, you realize that they relate to this, except that they have been reciprocated. There has been a reciprocal of it. I get what I'm trying to say. So when we are doing the mathematics or the arithmetic, you understand it well. And so now let's delve much deeper. So from the diagram here, you bear with me that this one will become, sine will now become, what is our opposite? Our opposite is what? Looking at the diagram, opposite here is what? X all over x all over y, right?
Yes, sir.
Then our cosine, causes adjacent all over hypotenuse, so it becomes z all over y. Then you bear with me that this one, the tan now becomes x all over
z.
X all over z.
Z.
Okay. Let me push this one. X all over z. Then this one becomes, the second becomes what? Y all over
Y all
z.
z.
Then this one becomes, cosecant becomes what? Y all over
x.
Y all over x. Then cotangent becomes what? Z all over x. So now we are going to prove something. Now, looking at this, you bear with me that sine theta, sine c all over cos c is equal to, will be equal to, do the mathematics using this values. Sine C is what? Sine C is x all over y. So sine C is x all over y. X all over y, right? Let me put them into brackets so that we appreciate it. Into bracket. Cos C is z all over y, right? Now, so when we have this, yes, mathematically, you know that we can do some cancellations. I hope you know that.
Yes, sir.
So now, when we do cancellations, do it. You are using your book. When you do cancellation, what are you going to get?
X all over Z.
So you are going to get x all over z. Now, so the x all over z, but you realize that the x all over z is equal to what? Looking at this, x all over z is equal to
cotangent.
No, x all over z is equal to tangent. Look at that's it, not the cotangent. That's it. This is it. X all over z, not z all over x. X all over z. That's it. Have you seen it?
Yes, sir.
So then now you can conclude that. So therefore, tan C is equal to sine C all over cos what? All over cos C. Oh, please, you had a problem with your network. Sorry. Can you see it now?
Yes, sir.
Ruben, can you also see it now? So now you can see, just looking at our calculations, where we said that sine C all over cos C is equal to xy, this xy all over zy. We were using this formula. Now, after cancellation, we are going to get x all over z. And so x all over z. Now, x all over z here is given by a tan. Tan is equal to x all over z, according to this. So now we can conclude that tan C and tan C, x all over z is tan. So then we can conclude that tan C is equal to sine C all over cos C. Can we conclude that?
Yes.
Ruben, do you agree?
Yes, sir.
So our first, this thing, what do you call it? Our first identity, tan C is equal to sine C all over cos C. This we've proved it using the right angle triangle. I hope you understand. Now, the short name for the cotangent, we call it cot. Now, let's also see cos theta all over sine cos C all over sine C. Cos C all over sine C. What do we have? Cos C is what? We are doing together z all over y, right?
Yes.
Into bracket, sine C is x all over y. So x all over y. Now, so sine C, looking at this, we can also do some deductions, or can't we?
Yes, sir.
So then we can now conclude that after doing the deduction, what are we going to get? Z all over x. So
Yes, sir.
this is also equal to z all over x. Z all over x. Now, looking at this one, z all over x is what? Z all over x is cotangent. Cotangent, or?
Yes.
Cotangent. So then, can we now conclude that cotangent, the short name of cotangent is cot. Cot is equal to z all over cot is equal to cos C, sorry, all over sine C. Can we conclude that?
Yes, sir.
PSA, do you agree or disagree?
I agree.
Now, let me also show you one thing. Looking at this and this, what is the difference? You realize that this is sine C all over cos C, and this one is cos C all over sine C.
Yes, sir.
So you bear with me that when we reciprocate one, you are going to get this. So then we can also relate the two, these two, tan and cot. So now we can also say that cot is equal to 1 all over tan C. Do you agree?
Yes.
Yes.
Okay, great. So we also have, so now we are deriving the distance ourselves. So we have identity number 1, we have identity number 2, we also have identity number 3. We are all doing it together. Identity number 3. How do we arrive? Now we can also consider sec. So now looking at the calculation we've done here, what is sec? Sec is hypo all over adjacent. So sec is equal to y all over z. But looking at sec y all over z and cos sec, what do you call cos and sec? Can you see some distance? Can you see some relations here? This is z all over y, and this one is y all over z. So can we now conclude that sec is equal to 1? Sec is equal to 1 all over cos C. Can you say it that way?
Yes, sir.
Ruben, can we say it that way? Looking at the two, cos is x all over y and sec is y all over z. So there's just been what do you call it, a reciprocal of it, or it's a reciprocation. So can we now say that sec is equal to 1 all over cos x, cos C, or cos theta?
Yes, sir.
Great. So you'll be noting them down. That's what we are going to use for our calculation. Now cosec, let's also see cosec. 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 So let's see cosec. Cosec is also equal to, cosec here is y all over x. Y all over x. But looking at sine 2, we have sine 2 to be x all over y. So can we now say that cosec is equal to, tell me here. Seriously, talk to me. Cosec will be equal to, looking at
I'm lost.
you are lost.
Yes.
Which part?
So the part that the internet connection was slow.
So which part? I won't be able to tell when your internet connection. But you understand all these things. You understand all these things.
Yes. Yes.
So now what we are doing now is just that we are just trying to see if we can relate all these things. We can relate them or derive some equations, or let's see, some equations or identity from them. So what we first did was that if you are given sine theta or sine C all over cos C, then it means that our sine here is x all over y. All over cos C, our cos here is z all over y. Now when we have this, mathematically we can cancel y and y.
Yes.
Now when we cancel y and y, then we are going to get s, you'll be left with x all over z or z. Will you bear with me like that, or do you understand it to that point?
So understand that, please.
So
please, what's the meaning?
Okay, talk
please,
to me.
what's the meaning of the SECANTC?
Is it this one?
No, the one before that one.
Is it this second? Is it second?
Yes, that.
It's also an identity,
yes.
like we have the tan, we have the cos, we have the sine. It's also another identity.
Okay.
You get it?
Yes.
So that is it. So cotangent, cosec, secant. This we call it, in short, we call it sec. We call this in short cosec, and we call this in short cot. So that's why I'm just trying to relate to them. So you realize that you are going to get x all over y, z, x all over z. Now x all over z here is tan. X all over z here is tan. So indirectly, it just means that tan is equal to sine C all over cos C. Are you getting it?
Yes, sir.
Yes. So that is the same thing we're doing for it. So here, looking at cosec, you bear with me that cosec is cosec. This is cosec, and cosec is hypotenuse all over opposites, right? Now hypotenuse all over opposite here is y all over x. Now let's see that we can relate y all over x to any of these ones up here. Y all over x, you can see that here today is x all over y.
Yes.
So this means that the reciprocal of this, the reciprocal of this should give us this cosec. When we reciprocate this, or when you find the inverse of this, it should give us this. Are you getting it?
Yes, sir.
That means when we divide it by 1, so when we say y 1 all over x all over y, when we do the distance, we can do the mass, and we are going to get y all over x. I hope you understand that mathematics.
Yes, sir.
If you don't understand, tell me so that I explain it again.
I understand.
Okay, Ruben, do you also understand?
Yes, sir.
So now we can say that cosec is equal to 1 all over our sine. So these are things you are supposed to understand. And when you understand, you should be able to do all these things. It should come handy. There's it. So now let's try one work. If cos x is equal to 9 all over 14, if cos x is equal to 9 all over 14, determine the value of the other 5 trigonometric ratios. This one, let's just do the other 3 or the other 2. So if cos x is equal to 9 all over 41, determine the values of the other 5 trigonometric ratios. So they said cos x is equal to 9 all over 41. Sorry. So can I claim
Is it 14 or 41?
41? Sorry, 41. So now let's do this. So they said cos x. Can I take away this? Can I erase this? Or are you done writing?
Yes, sir.
Yes, sir.
Okay. So the question says that when the class this thing, you join again and you do the last section, then you go and prepare for the chemistry class. So we have is that cos x. So cos x is equal to 9 all over 41. Okay, so we have this. The question says we should determine the value of the other 5 trigonometric ratios, but there are many, so maybe we just consider the other 2. So now the other 5 trigonometric ratios, we are just trying to see that we have cos here. So the other ones like the sine, the tan, and so on and so forth, we should determine them using the same thing. But looking at cos x is 9 all over 41. And looking at here, cos x, which is opposite all over, sorry, adjacent all over hypotenuse. Do you understand? Cos is adjacent all over hypotenuse. Cos x is equal to adjacent all over hypotenuse. So this means that here we can say that hypotenuse is equal to, the hypotenuse is what? 9. Yeah, adjacent is 9, and the hypotenuse is what?
41.
41.
41.
So looking at these two, we can use Pythagoras theorem. So now we can say that here is 41, here is 9. So we can find the opposite, can't we? Or can we find the opposite?
Yes,
Yes, sir.
So let's find the opposite.
Yes.
So what's the opposite? What are you getting? The opposite is equal to. Let's do the mathematics. What are you getting for the opposite? Using the Pythagoras theorem. Guess what?
40.
40. So the opposite is 40. 40 units. 40. So the opposite is 40 units. So now they said, now we've been able to get this. Now we are supposed to find the other trig ratios. So then now sine, what will be sine x? Given these numbers, what will be sine x? Sine x will be what? Sine x will be If cos x is this, sin x
Opposite over hypotenuse.
opposite all over hypotenuse. So sin x will be, in terms of numbers, sin x will be what?
4.4.
40 over 9.
40 over 9. Just give me in a fraction form. 40 all over 9. What will be tan? What will be tan x? What will be tan x?
Opposite over adjacent.
Opposite all over adjacent. So give me the number. I want the numbers.
40 over 9.
40 over 9.
Huh?
What will be what do you call it? Cosec. What will be cosec?
Sir, please, there's sin x. There's sin x.
It's supposed to be 40 over 41.
The cosec is 40 over what?
Sir, the sin x is
Yes,
40 over 41.
Okay, sorry, 40 over 41. Sorry. So what will be the cosec? What will be the cosec? What will be the cosec?
41 over 9.
Is that
41 over 9.
so 41 all over 9? What will be the cot? What will be cot? Cot, we can even look at this. Is the reciprocal of this. So cot will be 9 all over. Cot will be 9 over what? 40.
40.
Another one, what do you call sec? Sec x. Sec is the opposite of cos. So sec is 41 all over 9. Hey, sorry, I made a mistake. Sec is 1 all over cos. And we're giving cos to be 9 all over 41. Sec is 1 all over cos, yes. We're giving cos to be listen, so it will be 41 all over 9. This means that your cosec, the cosec you gave me is wrong. Cosec is 1 all over sine, and sine is this. So cosec will be 40.
41 over 40.
Yes, that is it. I hope we are all getting it to this point.
Yes, sir.
So there is one or two things we are going to. Now we are going to, when the class testing, we are going to start with calculating for the angles. I hope you have your calculators with you. I hope you have your calculators.
Yes, sir.
So we are
So
going
the
to.
cosec,
Which
you
one?
said is H, the cosecant, you said is H all over A. And you said it's also equivalent to 1 all over sine theta.
Sine
And
theta.
the
So
H,
where's my
and the
sine? So
H,
this is the sine. This is the sine.
so the H is 41 and the A is 9.
But I also give you the formulas for the, what do you call it? The cosec. I said cosec is what? Cosec is hypotenuse all over.
1 over.
Hypotenuse all over opposite, right? You are talking about cosecant.
Yes.
So hypotenuse